Okay, hi all. This is Herb Tanzer. I'm one of the co-chairs of the Green Technical Work Group. Um, Yesterday, Don Capps, in his presentation towards the end, broached a bit on the best foot forward. And this is his slide here. And essentially what he basically mentioned was that for each of the four SFS workloads you'll need to find during the test process, towards the end of the test process, you'll need to find the peak millibyte per second per watt for filers for each of the four workloads. And this essentially is what we're calling the best foot forward. And then there was also a mention of, besides this emerald defined best foot forward, there is, in addition to that, some additional test points that the EPA requires ultimately to define your qualified range, meaning your range of drive count for your tested storage system. And then there was there were a few questions that came up on that yesterday by a few of the folks on the call, and so we thought it best, SNIA thought it best that we review this perhaps a little more depth. So the best foot forward really is an emerald defined test point. And what it really is the optimal power efficiency data point, meaning the peak performance per watt storage system. And then, as I mentioned, in addition to that, the EPA has defined a couple of additional data test points, which Energy Star uses to define the so-called qualified range. And it consists of, in a high-level description, either the minus 40 or the plus 15% of the best foot forward storage device count, or you can also choose to do it another way, which is to determine from a test perspective your storage device count points where your actual performance per watt value is 15% less than the best foot forward point. And you get to choose whichever one of these gives you a wider range of the device count. I got my cat squeaking in the background here. Okay. So that's a real high level thing, and that's pretty much what Don said too. And so I think I'll go and present just a select set of the slides that was presented a couple of years ago during the version 2.0.2 Emerald training. And the name of the slide deck is basically product family, best foot forward, test points, and qual ranges. And I think we'll just start on slide 30 because it's a pretty lengthy slide deck. All right, now this is what was covered for the full slide deck a couple of years ago, and I'll just give a brief kind of a summary of the BFF, the best foot forward methodology, but really kind of focus in on just about maybe 10 slides or so that's within this this last bullet, the Energy Star test point qual range definitions. So at a high level, there's really many storage configuration range variables, but what you're allowed to do is to select a proxy family configuration, storage configuration, one that represents the vendor's most commonly sold and shipped storage device types. So you have that leeway. So that's what you get to pick from the get-go. And you'll need to figure that out. But again, it's the one that represents your biggest seller is really kind of what it comes down to. And then for a particular selected storage configuration, again, you get to select, it's the drive count of the storage capacity that varies, that needs to be varied to give you the peak performance per watt power efficiency data point. It's also referred to as a sweet spot. And then the EPA, in addition to that, requires a set of test points in order to determine a qualified range. Also, per the EPA, there are some allowable extensions to that, which I'll bring up. So we'll go straight to this part right here. Just quickly go through these slides. Get down to about slide 30, I think it is. A lot of these slides here describing a BFF methodology are kind of specific to the block, so it may get kind of a little confusing. So hopefully they're still very valid. Yeah, there we go. So I'd like to dive a little deeper into the Energy Star test point and qual range definitions. So we already went over this. There's the BFF performance per watt point. That's an emerald defined. And there's additional performance per watt points that the EPA defines. And again, the tester can select these several different approaches to give you the wider performance per watt curve coverage, or basically a wider range of qualified device count. So here's what we have here are just really conceptual graphical representations, which really helps the visualization. So here's the test point definitions for a scale-up system example. This is basically a curve of performance per watt versus the capacity, or device count specifically, drive count. And the very specific key test points are defined as the BFF, typically at the very peak. And then on either side, as you change the device count, whether less or more, you have the EPA prescribed minus 40% test point, minus 40% in terms of device count. DC1A. Then the EPA just prescribed plus 15% device count over here, DC1B here. And then the optional device counts are at 15% less than the BFF performance per watt point. So you can either be on one side or the other. So DCA2A is your minus 15% on this side as far as the performance per watt. And on the other side, DC2B is the plus 15%, or minus is the minus 15% performance per watt on the plus side of the device count. So any questions on this? This is really just kind of a conceptual framework of the test point definitions.
Is device count in full shelves or partial shelves or some other definition?
Here it's shown as individual devices, but one of the allowances or allowable extensions the EPA has is it can round up or down to full storage shelf counts when you actually claim a particular EPA qualified range. Okay.
Did we get an answer yet on what if we only sell one configuration and you can't increase or decrease drive count?
I would think if you truly just sell one configuration, it's all you really can test, really would want to test. Okay. Seems to me. Okay, so if all you were doing would be an emerald type of TDR or test data report, really all you're doing is providing BFF data test points. But for Energy Star, you've got more work to do. Submit the test data. You need these plus minus type of device counts tested. So specifically, what defines an Energy Star qualified product? So here we go. Here it gets a lot more detailed, and really this is trying to sort of summarize or simplify what is in the EPA storage EPA spec. So you have several options, option 1 and 2. First one is really what we're calling the fixed qual range, and the option 2 is what's termed a flexible qual range. So within option 1 or the fixed qual range, you've got several sub-options. You need your test points. You need to actually have your tested data points at minus 40 and plus 15% of the BFF storage device count. If that's all you do, okay, well then you can, and this is the most, I think probably the most common data submittal. You then get to claim a qualified range of minus 20 to plus 5% of the BFF storage device count. Again, this is EPA prescribed. And I think, and someone correct me if I'm wrong on this, like maybe Patrick, if you're on the phone, I think this is probably the majority of the actual Energy Star submittals. This is what they probably do. But there's yet another allowance, and that is if it turns out that the actual performance per watt values at the minus 40 and the plus 15% device count is greater than the that minus 15% level performance per watt, then you can actually extend your qualified range to the minus 40 and plus 15. I think we'll have a conceptual chart so clear. All right. So if you don't do without a whole lot of work, you can claim that minus 20 to plus 5 storage device count. With a little more work, you can perhaps widen your qualified range of storage device count. Now, another way to go at it, if it's to your advantage, this takes a little more testing. That if you actually test and find your device counts at minus 15% of the BFF value, then you can use that qualified range. This may be bigger than just this more fixed range. And that's what you're after. You got to kind of actually test this to see if that is bigger. If it is, great. You then can extend your qualified range to the values, to the device count numbers, plus and minus BFF, so they get the largest range. As mentioned here, you can also round up and down to your nearest drawer, full drawer. So here's a graphic representation, a few graphical representations that perhaps make this a little. This one I pondered a bit, and I think I had it corrected here, which is what I did. This is that option 1, the simpler version of option 1. Here shown again is performance per watt for your device count. What I put in is in the blue, because here at minus 40 and plus 15%, your performance per watt needs to be less than shown here in the blue. Needs to be it's actually less than the minus 15% performance per watt, and instead of here showing greater, at this point where it crosses the minus 40 and plus 15, it's actually a greater performance per watt. In this case, you really need to be less performance per watt than if you are less performance per watt than plus or minus 15%. Then you have this reduced qual range of minus 20 to plus 5. And then the other sub option, which allows you to extend your qual range, is shown here, where your performance per watt values at minus 40 plus 15, if they're greater, which they are here shown here, than your BFF minus 15 performance per watt, then you can use that full minus 40 to plus 15 qual range. Now, this is a little bit complicated, but hopefully I had to ponder these graphical representations again this morning, reviewing this to make sure I kind of understood this. But if you ponder these a bit, they should help make this a bit more clear. So again, this is all kind of put in words in the Energy Star spec. What we're trying to do here is give it a little bit more of a graphical representation, perhaps clarify a bit. So that's still option one of the fixed option, the fixed variable, fixed range, but with the widened minus 40 plus 15 qualified range versus what we showed before, just the minus 20 to the plus 5. And then this is your other option, big option, which is really the variable range. It's called the variable range, where if you actually measure the performance per watt at minus 15% on both sides of the peak, then you can use that as a qualified range, and you would want to use that if it's bigger than what you get from using the fixed. Okay. Any questions? And the EPA also has some what they call extensions. Oops. Some headers or extensions to the qual range, and it's just defined. First of all, you do need to get these test points for all of your active periods, like filer sense, your four different active tests, and you can round up and down to full drawers. Typical full drawer could be, for example, 24 drives per 2U drawer, JBOT or so. And then there's another approach, which is, in my opinion, definitely adds more complication, and I don't even want to cover it here. So there is a whole set of it's kind of an explanatory slide deck that John from the EPA put together that kind of goes through this, but this is definitely a much more complicated way of combining different combinations of device types. And there also is an allowance or an extension, which is what EPA provides, and that is you can, if you start with a particular device you've chosen, perhaps a device is your main seller or big seller device that you fully tested, you can replace that device with a similar or better one, meaning, for example, a higher speed or higher capacity. So you can kind of add those in so-called free of charge without doing a whole lot of additional testing. And then there's also the type of configuration is auto tiering. This is again a little more complicated and not fully baked yet as far as exactly how to do this, but some initial guidelines on this. Again, auto tiering is where you have some slower drives and faster drives, and that's taking advantage of the auto tiering software. But again, you start with your actual big seller systems in terms of the types of devices you have in there, and then you maintain the ratios of the device types as you go to your minus plus test points. Okay. And kind of to summarize your qual range is you base it. Your initial basis is you start with a proxy configuration that really, again, you get to select one that kind of best represents your family, one that is your biggest seller, so to speak. And then you do not really need to retest all the other drive types for that family. Now the BFF point still needs to be tested for each storage device. I'm not sure if that is. I'm not clear on this. It's really required. Anybody have a thought on that? Any of my fellow SNIA members or testers? I think this is covered by your allowable extensions. If you start with a so-called slower speed, lower capacity drive, you automatically can allow your higher capacity and higher speed. You can also allow your automatically do your solid state as well if you start with a spinning drive. So I'm not sure you still need to do this. To check a little more on that. So that's, I think, all I really wanted to cover. Hopefully this made it's kind of a refresher for me as well. I had to go back and kind of ponder this morning. But that's all I really wanted to share for today. Any thoughts, questions, comments?
This is Wayne just chiming in again. We do have a question that we posted to EPA to clarify if there's a fixed configuration of one set drive count, how to do this testing if this is required. So when we get that answer, we'll share.
I think one example I can provide is I think I was involved with one while at HPE. I was involved. One of the tests we did was we found a BFF, the best foot forward test point, which is right at pretty much at the max allowable drive count that was supported by that configured family, so to speak. So we really couldn't test a higher. Couldn't really test that plus 15% device count because we just couldn't do it in that system. So that's slightly similar, perhaps. Okay. Thanks for your attention.